Imagine a world hidden beneath the waves, a place where humans have dared to venture, build, and conquer. This underwater realm, often overlooked, holds a secret. The foundations of some of the world's largest bridges are built here, where sunlight rarely ventures. Yes, that's right. The ground beneath the sea is not just for marine life. It also serves as the bedrock for the towering structures that connect cities, facilitate trade, and make travel possible. These colossal bridges that we often take for granted have their roots firmly planted in the murky depths of our oceans and rivers. These underwater foundations, or caissons as engineers call them, require meticulous planning and precision. The process of sinking them to the seabed is a feat of engineering that is as remarkable as it is complex. These engineering marvels, hidden beneath the water's surface, are a testament to human innovation and determination. However, constructing underwater is far from a walk in the park. Just imagine, below the surface of the water, the world is a different place. The laws of physics seem to bend and twist in ways that can be challenging to comprehend. This is the reality of underwater construction, a realm where the familiar becomes unfamiliar and every task is a test of human ingenuity. First, we have the challenge of water pressure. As you go deeper underwater, the pressure increases, becoming a force to reckon with. This immense pressure can affect equipment, materials, and of course, the human body. It's like trying to build a sandcastle while an invisible giant is constantly pressing down on you. Next, let's talk about visibility. Underwater, the world is a hazy blur. The farther away something is, the harder it is to see. This lack of visibility can make precision tasks incredibly difficult. Imagine trying to thread a needle while wearing a pair of foggy glasses. That's what it's like trying to construct something underwater. Water currents are another major hurdle. They can be unpredictable and forceful, capable of sweeping away equipment or disrupting construction work. It's akin to trying to build a house of cards in a windstorm. Then there's the issue of corrosion. Water, especially salt water, has a knack for breaking things down. Metal rusts, wood rots, and concrete can erode. This constant battle against the elements adds another layer of complexity to underwater construction. These challenges, combined, make underwater construction a complex and dangerous task. It's not just about building something, it's about building something that can withstand the harsh conditions of the underwater environment. But despite these challenges, despite the pressure, the poor visibility, the unpredictable currents, and the relentless corrosion, engineers continue to venture into the deep. They are not deterred by these obstacles. Instead, they are inspired to find new solutions, to develop innovative techniques, and to use cutting-edge technology. Despite these challenges, engineers continue to venture into the deep, armed with innovative solutions and cutting-edge technology. They are the pioneers of the deep, pushing the boundaries of what's possible, and in doing so, they are reshaping our understanding of construction and engineering. The question then is, how do engineers overcome these challenges? The answer lies in a blend of human bravery, technological advances, and precise planning. There's an array of approaches that engineers employ to conquer the deep and construct these underwater marvels. One of the primary solutions is the use of professional divers. These divers are not just skilled swimmers, but are also trained in construction techniques. They become the hands and eyes of engineers in the deep. Despite the risks, these divers plunge into the uncharted depths, armed with their tools and their courage. They perform tasks such as inspection, repair, and installation, often in conditions that are pitch black and under extreme pressure. However, there are limits to what a human diver can do, and this is where technology comes into play. Engineers employ remotely operated vehicles, or ROVs, to go where humans can't. These are essentially underwater drones that can perform a range of tasks, from surveying the seabed to assisting in the construction process. ROVs can withstand extreme pressures, work in total darkness, and stay submerged for extended periods, making them invaluable tools in underwater construction. But it's not just about the people and the machines, it's also about the materials. Engineers use specially designed materials and equipment that can withstand the harsh underwater conditions. These include high-strength concrete that can resist the pressure of the water, corrosion-resistant metals for the structures, and waterproof electrical systems. Advances in materials science have made it possible to build structures that can last for decades under the sea. Of course, none of this would be possible without meticulous planning and modeling. Engineers spend countless hours in the planning stage, creating detailed models of the underwater site and the proposed construction. They use sophisticated software to simulate the conditions and predict how the structure will behave under various scenarios. This allows them to identify potential problems and devise solutions before they even start the construction. In addition to this, engineers also rely on a wealth of data collected from previous underwater projects. They study the successes and failures of past constructions to learn and improve. They experiment, innovate, and constantly push the boundaries of what's possible. They take calculated risks, always striving to balance safety with efficiency. And so, through a mix of human courage, technological innovation, and meticulous planning, engineers are able to create wonders beneath the waves. They overcome the odds, turning the challenges of the deep into opportunities for innovation. They take us into a world that was once thought unreachable, showing us that with the right combination of bravery, knowledge, and technology, nothing is truly impossible. As we look towards the future, the possibilities for underwater construction are as vast as the oceans themselves. The future of this industry is shimmering with potential, brimming with promise, and teeming with technological advancements that are set to revolutionize underwater construction as we know it. Imagine, if you will, smart materials that can withstand the immense pressure of the ocean depths and resist the corrosive effects of salt water. These materials, still in their developmental stages, could very well become the backbone of future underwater structures. Picture structures that are not just robust but also self-healing and adaptive, able to respond to changes in their environment in real time. Now, let's talk about the role of technology. The rise of robotics and artificial intelligence in the field of construction is no secret. However, in the world of underwater construction, they hold even more promise. We're talking about autonomous underwater vehicles, or AUVs, capable of performing complex tasks that would be risky, if not impossible, for human endeavors. These AUVs could be employed for everything from site surveys to actual construction work, increasing efficiency while reducing human risk. Moreover, advancements in 3D printing technology could open up new avenues in underwater construction. Imagine being able to print customized components right on the construction site under the sea, reducing the need for transporting heavy materials from the surface. And let's not forget about the potential for renewable energy solutions. Tidal and wave energy structures could be built on the sea floor, harnessing the immense power of the ocean to generate clean, renewable energy. These are just a few glimpses into the future of underwater construction. As technology continues to advance and we push the boundaries of what's possible, we can expect to see even more impressive underwater structures in the years to come. With these advancements on the horizon, the future of underwater construction is set to be as exciting as it is challenging. Are you intrigued by the world of underwater construction? Perhaps you've found yourself captivated by the intricate dance of machines and humans, working in unison under the vast, unexplored depths of our planet's oceans. Or maybe you're enticed by the sheer audacity of human innovation, the bravery it takes to conquer the unknown, to quite literally build the foundations of our world beneath the waves. Consider this as your invitation to delve deeper, not just into the water, but into the fascinating field of engineering that makes such feats possible. Underwater construction isn't just about building bridges or laying cables. It's about pushing the boundaries of what's possible, about expanding the horizons of human habitation, and about safeguarding our future. Imagine being part of this realm, where every day is a new challenge, a fresh opportunity to make your mark. The rewards are immense. There's the tangible satisfaction of seeing your designs come to life, of course. But there's also the knowledge that you're contributing to something bigger. Your work could connect communities, foster trade, protect our coastlines, or even unlock new scientific discoveries. In this field, the possibilities are as expansive as the oceans themselves. As an engineer in underwater construction, you're not just a builder. You're a pioneer, an innovator, a guardian of the deep. What does it take to be part of this adventure? A spirit of curiosity, a willingness to learn, and the courage to dive into the unknown. An education in engineering is your gateway, but it's your passion that will propel you forward. So why not embark on this journey? Why not immerse yourself in a world that combines the thrill of exploration with the satisfaction of creation? The world of underwater construction is waiting for you. It's a world where you can make a real difference, where your work can have a lasting impact. Dive into the world of underwater construction, and you might just discover a passion for engineering that runs as deep as the oceans themselves.